Now I'm outdoors, well away from any plumbing or electric cables or stuff. The blue track is the electric sensor, the red track is the magnetic one. The magnetic is oriented for maximum signal, and I will now move the electric, and I hold it like this. And you see that is maximum. And now I turn it horizontal. Exactly horizontal, there is a 0. And in this direction, the horizontal is like that. It means the field is not distorted by conductors in here, and I can see that the sensitivity of the electric sensor is about 10 dB better than the sensitivity of the magnetic sensor, and that is at, where do we have it? 950 kilohertz. So I repeat at some other frequency. So here's the minimum for the magnetic, and I turn 90 degrees to get the maximum. And then I lift the electric sensor from the grass. And the electric is, it varies with time, but it seems clearly no longer. The QSB dip was not at the same time for both sensors. That's interesting. But the difference is something like 6 or 10 dB. And the electric field is pure vertical. And now it comes up and we see a 10 dB difference. Seems I made the magnetic sensor a little bit too small. Now I made a magnetic sensor that is about twice as long. And now the blue is the electric and the red is the magnetic. And they don't differ very much in amplitude anymore. This is at 1 megahertz. And now it's 1.25 megahertz, and they are still about the same. Also here at, what is it, 695, I think. The new bigger magnetic and the electric sensor, they are fairly similar in sensitivity. This is very nice, because now when checking for interference, I know that they have reasonably much the same sensitivity. This 1970 style radio is modified. The ferrite rod is no longer in there. It is replaced by a toroid having the same inductances as the windings had on the ferrite rod. I have put a single transistor amplifier in front of it. The toroid is there to provide the normal selectivity. It's the only tuned circuit in front of the mixer. This radio is connected to the electric sensor here. The camera is not only a camera, it's also a computer, and it's surrounded by electric and magnetic fields. So when I come close to the sensor, this is about 3 decimeters, and if I go in the plane of the element, I can hear it up to half a meter away, and it's of course symmetric. But if I approach the center, and it's very important to keep my arm and myself near the center line, because if I put the camera at the center while standing near the tip like I do now, I find the point where the coupling is 0 not at the center anymore. Now I will take a walk around the house with the electric sensor. Now holding vertical, and I can change the horizontal, and I can go around and check the other horizontal. Here we have some interference. It comes from the source. That's the laptop with the ephedry on it. Here is a maximum on the lamp. It's switched off. It's just a cable. Something else is injecting current into the cable, and there becomes a voltage peak at the end of the cable. These are fluorescent lights. And there is something here. It's the fluorescent light in the floor below, in the cellar. Here. With all these lights, this is a horrible place for electric dipoles. Downstairs. This one is nearly quiet. And this one is not. And there are more lights around. Not very difficult. The washing machine has a computer in it. And this one, but the fluorescent light here is not so bad. But the fields are very local. You can hear it's not much here. That's only a few meters away. I switch off. Also these are gone, but this one perhaps? No, it's something else. It's from here. Somebody's calling on the telephone. So I switch off the light. And it's this halogen light that has a poor power supply. And that was the dimmer, because these halogen lights have an old-fashioned transformer, but there is a dimmer in front of it. Please. So this is the kitchen stove. There is a fluorescent lamp in there. That is the cellular phone. This is a quiet fluorescent lamp. This is also quiet. But that laptop is not. And that's my Pentium 4. This is another computer. And that is a modern low energy lamp, a fluorescent lamp again. This is really strong fluorescent lamp. And here is a computer without any metal on it. And there is no interference. And I go out here. And it's again fluorescent lamps. The glow lamp is harmless. And these computers are nice. There are no electric fields surrounding them. Probably there are magnetic ones. I haven't checked that yet. Here is another computer. And as you can see, When I approach metal with this electric sensor, it couples to the whatever is in the cable, and the cable can be an antenna and pick up desired signals, or it can be connected to the telephone system, like here, which is to the ADSL. And now I'm back here. And the power supply. Now I take a walk with the magnetic sensor, and of course the desired signals, the radio stations, they are minimized when the rod is vertical. And this is the same frequency as I had before. That's the computer. And the power supply.
La combinaison d'âme illustre aussi qu'on parle pas d'une même voix.
And there are magnetic fields around the computer. The screen. Not too bad. I switch on the electric fluorescent lights. And you can hear they give magnetic fields also. They both use high voltages and high currents. And here we had one that was really bad. This one. And the cellular phone is quiet magnetically. And this one was quiet electrically. And not very noisy, some noise. This one was very bad for the electric fields, but it's no problem magnetically. One is bad, electrically as well as magnetically. Should be obvious from this little walk that the interferences are very local. It's just dipole fields. And I had to come pretty close to really get big problems. Now I'm outside in daytime. There are no medium wave stations, but the interference from the house can be heard. So here the electric field points outwards. The vertical component is small. And it's the same on many places around the house, but it disappears rapidly with the distance. So when I walk around, it looks like this all the way around. And I cannot go around the corner here because it's blowing a little and the camera doesn't tolerate it. This is the dimmer in the kitchen. It's up here. I can hear it at a distance of about 5 meters. Now, this antenna is of course not very sensitive, so a good antenna would hear it at a larger distance, but not very much larger. Here is a very simple antenna. It's just a wire from the window, a little wire going to this little tree here. And look at what happens. So this little wire is a capacitor into the noise source, and it emits a lot of interference. Of course, in the other end, where there is a Perseus receiver, there is a lot of noise on the receiver input. This is not the way to make a medium wave antenna. Here is the Perseus with this antenna. The blue wire can be connected to ground. Right now it isn't. And the Perseus screen looks like this. When I disconnect the antenna, it looks like this. You can see the noise floor is at 0. And I connect it again. And the noise floor is about 30 dB. I connect the ground to the element here. And you can see it's about 10 decibels lower now, the noise floor, but the structure is different. There are interferences that are not weaker. And I disconnect the ground connection again. The simple wire antenna is fed with a noise voltage through the 50 ohms of the Perseus, causing a noise floor at about 30 decibels. That current is enough to be sensed with this. So the demonstration with the electric and magnetic sensors on the antenna give an idea what they really are intended for, these sensors. It's to check how the antenna, the real antenna, is isolated from the house. How balance and ground points should be arranged to make an antenna quiet. And I walk a little bit around the house and I have the situation. The fields reach about the same distance as the electric fields do. And that is probably the cable. It is a good idea to stay away from cables like that. And I walk on the grass. Then one might be surprised that they reach so far when I walk in this direction. But that is because here is a cable, and when I put the sensor parallel to the cable, there is of course no magnetic field. This is not the place where to put the magnetic loop antenna. And about 5 meters away from the house, there is still some magnetic noise. And when I approach the kitchen, here at the corner of the house, we have this horrible dimmer. That's for the lights. You can see far away there. And here is another cable. It's the telephone line. Follows the road all the way out. And of course the field stays constant all along the line. And here is the cable for the lamp. But I can still hear some magnetic noise this far away. But most I hear white noise. That's just the atmosphere or maybe some carrier. This is a highly sensitive width antenna. I am about 30 meters away from the house. That's how far I have to go to have noise, to not hear the fluorescent lights anymore. It's tuned to about 600 kilohertz, as you can hear when I tune it. There is a faint trace of fluorescent light hum, as you can hear. Now the highly sensitive antenna is about 15 meters from the house and is blowing. I don't know if this can be heard. I will tune it a little bit. So this is about 15 meters away from the building. And I wish I had a separate microphone for the camera. Now I am far away enough from the house, but right below a power cable. And this is of course a very unsuitable place for an electric sensor like this with antenna. If I disconnect it, you can hear how strong the signal is. Here there is no chance to hear anything that is not a strong medium wave station. Now I'm again about 30 meters away in another direction with this high sensitivity antenna. I can tune the radio if you can hear a little bit. And there are faint radio signals because the sun is not high on the sky anymore. It's up there. It's 5 o'clock in the afternoon. The toroid has about 100 turns on the antenna side and a single turn on the receiver side. It is 50 ohms at 600 kilohertz. And what we hear does not come from the house. Now I have replaced the toroid with a source follower and a battery. A very simple amplifier. This means that I now have a wideband width antenna. And I am about 30 meters away from the house, and I can tune the frequency. The time now is 6 o'clock, 6 p.m. And maybe you can see where the sun is. I don't know if the camera is smart enough. The sun is still pretty high over the horizon, so medium waves are still weak. The whip antenna with the source follower already gives some signals when I am outside, about 30 meters away from the house. I can hear a lot of medium wave. On the Perseus I hear only the interference, and if I connect ground to the element, to the heat radiator, or what you call it, the noise floor goes down again by 10 dB, but there is no sign of any medium wave broadcasting. It's still too early in the day for this very noisy antenna. Now the time is 8 p.m. The sun is near the horizon, but it hasn't set quite yet. I'm listening to the Perseus on this very bad antenna that goes through the window here and into the Perseus, to the center connector. There are many medium wave stations now, and I connect the ground cable for the Perseus on this part of the heating system. You can see what happens here. The noise floor goes down by 10 dB, but this station was good enough already, so we don't hear much difference. I'll try some weaker signal, maybe this. So that was not really unexpected. What is unexpected is that we can hear reasonably well despite this lousy antenna, and already at this time. Now it's dark. It has been dark for an hour or two. It is 15 minutes past 10 in the evening, and I can click on the strongest station here, and it sounds very well, and I can tune a little bit around. That means press down the mouse and move it.
Aus dem hehren Tonfall der Beethovenschen Komposition.
Rien gagné depuis 11 ans, depuis la Coupe de la Ligue.
He was only 20, and that was such a powerful song at the time.
And up here, oops. This is just a Pentium 4. It has hyper-threading, but anyway, half a megahertz bandwidth is a little bit on the high end for this thing when a new station is clicked. Then Linrad has to recompute data for some period of time. So I restart and go back to medium waves. And here we are, and I click some. And here we can hear the interference quite well, so I connect the ground wire. And that makes a really significant difference here. But with a proper antenna, it will be dramatically better than this. Now I'm using the whip antenna with the source follower and a battery, and it's isolated from the house by use of a ferrite transformer, 2 windings on opposite side of a fairly big ferrite core. So, and the whip antenna is standing 30 meters away from the house, and the house doesn't cause any interference at such a large distance. And I can click some stations here and you can listen. I can use the arrows, left and right arrows, to change frequency. And I don't know anything about what stations these are, but there is nothing of the characteristic fluorescent light QRM. But all the fluorescence lights are switched on right now. Not even here when there is only a very weak signal. The multiple cursors is a bug, presumably because I'm running on a computer that is rather slow, so I haven't seen this before.
Er ist der Mörder und möchte bei ihm arbeiten. Und ich finde das ganz interessant.
Here's a quiet region. There is something, but I don't think it comes from my house. It's probably radiated from somewhere. Now I go to a low frequency. I go here and set, let's say, 300 kilohertz. Sorry, 0.3 megahertz.
Were tentative.
So this is long wave, 300 kilohertz.
We kept to our
C'est une continuité absolue de...
I don't know what this is. It's 64 kilohertz. Now I have removed the isolation transformer, this thing. It makes a big difference, as you can see. I go to higher frequencies. And you can see that higher up it's not as bad. I am in SSB mode, so I go for AM again. X, X, F. and for the medium waves here. Oops. Once more. But if I go for a weak station and this problem again, I will run on a faster computer next time. X and but this was standing by the window, was convenient from that point of view. Yeah. And I try to connect the ground on the heating system. So it's clearly something that we send out to the antenna from the house on the cable. And I go down in frequency again, where it is worst, and put the isolation transformer at the Perseus input. As you can see, the isolation transformer helps a little bit. It's sitting here now, but by far not as much as it did when it was mounted near the antenna. And I can connect to ground on the antenna side, and you see it's much worse. And I can connect on the radio side, and it doesn't make any difference. I will show more about this tomorrow when it's daylight.